Let's look at this question relating to age-based retirement, right? Where we are seeing details of a person being provided, wherein we are talking about the pension part as well as the lump sum payable part also. So here we are talking about the death in service kind of a benefit, and here we are talking about the age retirement. How do we typically derive the numbers? Okay. Under the rules of a pension scheme, a member may retire due to age at any age from exact age 60 to 65. On age retirement, the scheme provides a pension of 1 by 60th of the final pensionable salary for each year of the scheme service, subject to a maximum of 40 by 60th of the final pensionable salary. Only complete years of service are taken into account. And we are defining the final pensionable salary as the average salary over the 3-year period before the date of retirement. So all these things, now probably if I am saying ZX, it is nothing but 1/3 of Sx minus 1 plus Sx minus 2 plus Sx minus 3. This is what I can define Zx as. And the pension amount we are talking about 1 by 60th of the final pensionable salary for each year of service. Pension scheme also provides a lump sum benefit of 4 times the pensionable salary on death before the retirement. So this is not on 4 times the salary, this is 4 times the pensionable salary. The benefit is payable immediately on the death, and the pensionable here the pensionable salary is annual rate of salary at the date of death only. So on the date of death, whatever is the annual rate of salary, that is what going to be. Now we are talking about for a specific member whose date of birth is 1st Jan 1979 and he has joined the scheme on 1st Jan 2000. Means he was 21 exact when he has joined the scheme. Annual rate of salary as on Jan 2005, which means when he was 26, his salary is 50,000. But the date of last increase of the salary was 1st April 2004, means at that time his age was 25.25 years. Right, so these are some of the important aspects that we have to look at in terms of computing past service as well as future service pension liability based on the age. Along with that, we also are required to compute the lump sum payable on death before the retirement. Alright, so we can directly bring out the expression. Right, we will try to bring out the expression first with respect to the past service. Okay, what is our expression now? Few things we have to understand here. Past service is basically, we are assuming that the retirements are typically occurring uniformly anywhere between 60 and 65. But once he reaches 65, it's not between 65 and 66. At 65 only they are going to occur. So we know that Zx we have already defined, which is 1/3 of Sx minus 1 plus Sx minus 2 plus Sx minus 3. Which means now if I have to look out from a person's perspective, probably if let's say I am talking about he is retiring at x plus t kind of years, especially currently he is 26. So he is retiring at 26 plus t kind of years, which means Z26 plus t will become S26 plus t minus 1, S26 plus t minus 2 plus S26 plus t minus 3. So this becomes Z26 plus T. Okay, now with these things, a person whose current age is 26, right, he may die anywhere between 26 plus T and 26 plus T plus 1 for different values of T. Or he may retire, sorry, he may retire anywhere between 26 plus T and 26 plus T plus 1. So this T could be anywhere between 34 to 38. Because if it is at 34, then he is retiring for 60 years. If T is 35, it is 61. If T is 38, then it is 64, between 64 and 65. And if exactly T goes to 39, it is at 65 years. Now, what is the past service for him? Now let's verify the past service. He has joined the scheme on 1st January 2000, and we are trying to do the valuation as on 1st January 2005. So the past service which he has put up is exactly 5 years, which means for the past service we are talking about a pensionable salary of 5 by 60th. What was his salary at that point in time? 50,000. And now if he is retiring at 26 plus T, so assuming that somewhere in the middle the retirement is going to occur, the salary increment is going to be Z26 plus T plus half divided by S 25.5, because the last salary increment has occurred when he was 25 years of age. So I have to differentiate, I have to discount this entire thing by T plus half years. So what I'll do is I'll do it as 20 V per 26 plus T plus half divided by V per 26 and multiplied by the probability of retirement. So R 26 plus T, in that particular year, what is the number of people who are going to retire, provided those people who were there at 26 in the population, how many proportion of the people are going to retire, and this entire thing. So once they retire, from the date of retirement until the date of death, their pension they needs to receive. So the present value of the pension is going to be A 26 plus T plus half, probably on a continuous basis they might be receiving. So this is what is the expression, and probably the numerator entire thing Z26 plus T plus half, V bar 26 plus T plus half, R 26 T and A bar 26 T plus half, I can still call it as ZC 26 plus T for retirement. This entire thing I can call ZC 26 plus T for retirement. And the denominator S 25.5 V per 26 L 26, I can call it as SD 26, and this is multiplied by 5 by 60 times 50,000. So this is what I can give, especially for retiring anywhere between 60 and 65. But the same logic, if I have to retire at 65 exactly, I'll, instead of 26 plus T and all, I'll take it as ZC65 RA divided by SD26. And how does this 65 come? This becomes A bar 65. This becomes Z65, V power 65, R65. And the denominator will still remain the same. And if I am taking all these have to be summed up over the different T's. T equal to 0 to, I have to sum up, probably right from T equal to 34 to 39, I have to do the summation. So that summation I can still call it as ZM60RA. right? Because any of from the 0 if I am doing, there is no retirement for t equal to 0 to 34, so all those will become 0. So only from 34 to 39 the summations I can take it as ZMRA60, and that divided by SD26 multiplied by 5 by 60 multiplied by 50,000. So that is what is going to be there for the past service benefit. Now the same thing if I have to look at for the future. Okay, now also the retirement can happen anywhere between 60 to 65. But think of it here, at the max 40 by 60th of the pensionable salary is being paid, which means he has already put in 5 years. So and his age is 26. So if he is going to retire anywhere between 60 and 65, probably T would be 34, which means 39 years of service is going to come. But if he is retiring anywhere after 61, 61 to 62 or 62 to 63, in all those cases, he is directly receiving 35 years only, because 40 by 60 of the pensionable salary is already coming out. So only if the retirement is occurring between 60 and 61, the number of future years I will take it as 34. But if it is anything above 61, I will take the number of future years as 35 only. I will not increment year over year, because 40 by 60 is already getting met. Right? So 40 by, because the 40 by 60 is already getting met. So which means at least for between 60 and 61, I will take it as future service benefit as 34 by 60 times 50,000 is the amount. And okay, this person is retiring at 60 and a half. So the salary part is 60 and a half divided by S25.5. I have to discount it again by the same 34 and a half years. So I'll take it as V per 60 plus half divided by V per 26. Then R60, the retirement at 60 divided by L26, and the present value of the annuity from there A60 plus half. Now this entire thing again can work out simply as 34 by 60 times 50,000, and with our notation I can write it as ZC60 RA, and the denominator I can very well write as SD26. Now this has to be done. So this is when he is retiring at 60 or between 60 to 61. But if he is retiring between 61 to 62, it is going to be 35 by 60 times 50,000 times ZC61 RA divided by SD26. So if I look at all the possibilities, then it is very much coming out to, the summation is coming out to 50,000 divided by, or 50,000 divided by 60 into SD26. Here it is coming 34 times ZC60 RA plus 35 times ZC61 RA, 32 times ZC62 RA, and so on. And that is going to be, I'll define it as ZM bar 60 RA, wherein I'm directly taking this entire summation as 35 times ZC60 plus T RA, and I am subtracting 160's RA minus ZC60 RA. If I am subtracting, that is what is going to give me the ZM bar 60 RA, which is going to be the future service related benefit. Now the same logic if I have to apply with respect to the death related benefit, right? We have said that it is 4 times the pensionable salary. Now the salary currently is 50,000, 4 times that salary. So the salary I am expecting at the time of his death is going to be currently whatever is his salary, 26.525 plus T divided by S 25.25. So this is his salary when he is dying during the period of T, right? S 26 plus T plus half, and the same has to be discounted. 26 plus T plus half divided by V power 26. The probability of death D26 plus T by L 26. So I could very well find out what is, I can again take the commutation function, the numerator I can call it as SC 26 plus TD. This I can call as the numerator part of it. Denominator I know that I can call it as SD26. And if I had to add up all these present values, this entire thing has to be summed up over, because the death can happen anywhere before the retirement. So this has to be summed up over 0 to 38 period. And all these summations I could, the numerator summation I can call it as SM26 for a death, and that's it. So we can, so the commutations wise, initially we have to express this kind of number, express this kind of expected present, expected future cash flows, identify the present value associated with the future cash flows, then define the commutation function for each of these calculations, which is simplifying the whole process in terms of arriving at the present values of both the death benefits, or as well as the past service, future service pension benefits as well. All right.